Good afternoon. Today is Wednesday, September the 23rd. Today in pre-calculus, we looked at nonlinear inequalities on page 141. I'll go ahead and share my screen here and show you an example of one of these inequalities. So when we get into nonlinear inequalities, we're looking at situations that have something like a third degree. So here we have, if I go back to my text here, we have a function which says 3x cubed minus 4x squared minus 13x minus 6 is greater than or equal to 0, or rather less than. So I'll go ahead and put the less than in here like this, less than or equal to. Now, if I factor this down using my synthetic division, and when you try to do that, if you plot this graph on your calculator, you can find the numbers to use for synthetic division, but I will get a set of linear factors, which are x plus 1 times 3x plus 2 times x minus 3. Okay, so this is less than or equal to 0. Now, so if you remember, big number here. Okay, all right. So if you remember, when we drew the graph of a function like this, here we go, my cursor. Okay, we draw our picture here. This is our axis. Now, we have an intercept here. If we use our endpoint behavior, third degree function is going to start down here in the third quadrant, and it's going up here into the first quadrant. And what we see here, we have a root at -1 here. So this is going to be a -1 root. And then we have a root at -2/3, which is fairly close here. So this is going to be our -2/3. And then we have a root over here at +3. So we can make this +3. Now, so if I draw my curve, I'm trying to get this. Okay, so I'm going to start down here in the third quadrant. It's going to come up like this. It'll come through this intercept. And it'll come back down like this and go through this intercept and go through it -6. And it's going to come up and go through that intercept like that. Now, if I'm looking at the points where the curve is less than or equal to 0, that means the graph is below the x-axis here. So I can look and see, okay, everything to the left of -1 is a good solution. So I can say x is less than or equal to -1, or x is between, so I get x is greater than or equal to minus 2/3. And less than or equal to 3. Okay, now if you wanted to, that's what I call a graphical approach to the problem. So if I come up here and look at an algebraic approach, if we draw a number line down across here, and you notice my number line, I make a tick mark on it for every one of my intercepts. So I got an intercept here at -1. I've got an intercept here at minus 2/3. I'll get this thing working here in a second. Minus 2/3. And then I get another one over here at +3. Now, so what this does is it creates 4 regions. It creates a region here, creates a region here, creates a region here, and it creates a region here. So if I take and put in like between minus 2/3 and 3 here, if I pick the point 0, which is in that region, and I stick it into my equation up here, I get a function value of -6, and -6 is less than or equal to 0, so this region is a good region. And then I can put in, say, 4. I put it down here, I get 5 times 12 plus 2 is 14. 5 times 14 is 70. And then I put in times 1 here. So that's 70, which is, that's not a good region because that's too big, so I could cross that region off. Now, what you'll find out, if you have linear factors like we have here, then your valid region and your non-valid regions will alternate. So since this one from minus 2/3 to 3 is good, and we know that this one here is not good, and we know that this one over here is good, and that's consistent with what we saw from the graphical approach. So you have your graphical approach here, or you have your algebraic approach down here at the bottom. So I will stop sharing now. If you have any questions about this, we'll look at this some more tomorrow, and we'll look at some rational functions and try to do a little bit more work with them. So I will get back to you on that. Now, the test for chapter 2 will be next Tuesday. So I will get with you and let you know what your requirement is for that test. So any questions, give me an email.